let's continue on finding those exact values of trig functions. In other words, sine, and again, what are their trig functions? Sine, cosine. We'll learn about these in the next sections: tangent, cotangent, cosecant, and secant. So there's 6 of them, by the way. Okay, so here are the values you're gonna need to have these memorized. Believe me, when you come to calculus, no one will sit and wait for you to figure out what sine of pi over 6 is. And by the way, when you get to calculus, you will just use radians. The degrees are nice. They're much easier to remember or think about, because the computation, adding, subtracting degrees rather than adding, subtracting these radians, which you see they're all fractions, is going to be much easier. So that's why I'm still talking about degrees, because in case you forget, you can always go back quickly to degrees, and the computation's much easier, and then you go back to radians. Okay, but I will show you what I mean. So I was mentioning in the last video that we can extend these fancy angles, which again, these are going to be 30, 60, 0, 30, 45, 60, and 90. And by the way, yes, 0, pi over 6, pi over 4, but who really thinks about these fractions? This is much easier to memorize, right? That's what I'm saying. We'll extend these values that we've just learned to angles around the circle. So we're going to talk about something called reference angles. And the quadrants. So by the way, let's start with the quadrants. If you see, and again, we're going back to this unit circle because that simplifies all our computations greatly. Okay, so again, how do we find sine and cosine values of numbers? We just go around the circle till we get dizzy. Yes, sine of 5. We'll start right here and go 5 of these units, right, around the circle till you probably will get to quadrant 4 somewhere. And then what do? You pick the y-coordinate of that point, right, for sine. So as you see, if your angle terminates in the first quadrant, like 0, 30, 45, 60, and okay, 90, of course, these are quadrantals. But if your angle terminates in the first quadrant, then means what? The sine value is a positive, and the cosine value is a positive as well, right? Because x and y in first quadrant, right, wherever point I might end up on, right, that's the sine value, that's the cosine value of this number up to here. They're both positive. In second quadrant, what happens in the second quadrant? Well, the x values are negative, so cosine is negative, but sine value is positive, yes? In third quadrant, you are in third quadrant, so both x and y are negative, so both sine and cosine will have to be negative values, yes? And finally, in quadrant 4, sine is negative, right? The y's are negative, but cosine is positive, right? So there you have it. Okay, so that's good to know. Maybe you even know a mnemonic that says all students take calculus. So in first quadrant, all trig functions will be positive. In second quadrant, sine is positive. In third quadrant, tangent, which by the way is the ratio simply between sine and cosine. So when you divide two negatives, you get a positive. And the fourth quadrant, cosine is positive. All students take calculus. Okay, I know I'm getting a little bit ahead of myself because I'm talking about tangent, but again, I know you've heard of it, okay? So this is the sine, so that's going to be important. It's going to be important in what quadrant we are fitting, right? In what quadrant we're terminating, right? With that value or with that angle, okay? Second of all, what are reference angles? Well, let me tell you. So we can bring everything back to the first quadrant. So an angle in first quadrant is equal to its reference angle. Okay, what is a reference angle? Jesus, what the heck am I talking about? Okay, so let's go back to what a reference angle is, and I'm going to put it, I have some room here before. So the reference angle call it, I'm going to use the notation we're using in the trig book, theta hat of an angle theta. So if you start with an angle theta, its reference angle, call it theta hat, is simply the positive acute, so the reference angle is always a positive, acute angle made between the terminal side of theta and the x-axis. Okay. The terminal side of theta and the x-axis. So let's see how we find reference angles for angles. Okay, so I'll put this aside. There it is. It says an angle in first quadrant is the same as its reference angle. Okay, so what does an angle in first quadrant look like? An angle in first quadrant looks like this. Okay, terminates in first quadrant, yes? And by the way, so here it is. Of course, this could be an angle in first quadrant as well, but this is what I mean. So an angle in first quadrant is what? What did I say the reference angle is? Is the angle made by the positive acute, so less than 90 degrees. Angle that's made between what? The terminal side and the positive x-axis. So that's the same thing. So it always has to be an acute angle. Let's think about an angle that terminates in second quadrant. Okay, so let's see what this would equal to. Now, if you terminate in the second quadrant, I don't need a circle. If you terminate in the second quadrant, then you're somewhere here, yes? So that's your angle theta, okay? And we'll keep it simple, right? Positive, one time around the circle. Let's not go to the negatives, yes? So what's the reference angle of this angle? This one has to be, again, the positive angle between the terminal side and the x-axis. So what completes it all the way to the x-axis? So this is my reference angle. And again, keeping this, let's say, in degrees, positive, right, going from here to here, the reference angle is simply what completes the 180 degrees, right? It's between the terminal side and the x-axis. And it's the acute angle, right? So this would definitely not be it going back this way. So the reference angle, these are the same, yes? But the reference angle is simply 180 degrees minus this theta, or if it was in radians, pi minus theta, okay? So this plus that adds up to 180, right? To the full straight angle, to the straight angle, I should say. Okay, let's move on. We'll practice on all of this. An angle in third quadrant. How do I find its reference angle? Well, let's draw a picture. And really, many times, even though you have these formulas, I wouldn't recommend. You just draw your picture. So here's an angle that terminates in third quadrant. Okay, so what do I have to pick? I have to pick the acute positive angle between the what? The terminal side and the x-axis. Now, of course, I'm not going to go this way because that's not acute. It's more than 90 degrees. So I have to go back here. This is my reference angle. Okay, so the reference angle is simply going to be theta minus 180 degrees, or theta minus pi if you're using gradients. Why? This thing, I have to simply do what? Take the 180 away from theta, right? So bring it back just to the negative x-axis, right? So we're just minusing 180 away from it. Okay. And finally, an angle in fourth quadrant. Okay, let me draw one for you. Here's an angle that goes all the way to the fourth quadrant, yes? That's its terminal side. What is the reference angle? Well, I have to go from the terminal side to the x-axis, shortest way possible, right? In other words, the less than 90 degrees, right? The acute, right? The less than 90 degrees, the shortest way back to the x-axis. So here it is. So the reference angle is simply going to be 360 minus theta, which is the same thing as 2 pi minus theta if you're using gradients. Why? Because I simply have to complete, right, from this theta plus this reference angle completes the full circle, right? The full 360 degree angle, right? So they're going to add up to 360. So that piece is here what's left over to 360. Okay, so why are reference angles so important? I'm going to say this. The trig values of an angle and its reference angle are the same or opposites of each other. So the point is, the sine value of some angle theta is itself or the opposite of the sine value of its reference angle, right? So they're the same or minus. It depends what quadrant you terminate in, right? Remember, a reference angle is always positive because it's always an acute angle less than 90 degrees, so it fits in the first quadrant. And so, of course, the same thing for all the other ones, right? And when we'll talk about tangent, cotangent, it works the same way. Okay, so let's just do that. Last piece of the puzzle. I want to find, really important, when I say find the exact value, you do not touch your calculator. Find the exact values of the following. And not only that, the exact values, okay? So don't tell me 0.79 blah blah. That's not an exact value. Okay, of the following. And to keep it simple and just to make sure you get the right angles, first of all, I'm going to ask you to do these things to find that exact value. I'm going to ask you to draw the angle. We practiced that in 5.1. Draw the angle in standard position, of course. How else would we measure anything? Second of all, find the reference angle. So you'll have to do the same thing on a test that I know you didn't just put in your calculator. Find the reference angle and then find the exact value. And that, as I said, completes the puzzle. Okay, so here it is. I want you to, here's an angle. I'm going to say 300 degrees, okay? So I want to do these things, and then I want to find the exact value of the sine and cosine of that angle. Okay, so here's my angle, 300 degrees. Let's draw it. So in standard position, 300 degrees starts here, and it goes positive 270 and a little bit more, right? So this is my angle theta. Now, what is its reference angle? Because we're in fourth quadrant, reference angle is, again, made between the terminal side and the x-axis. So if this is 300 degrees, how much more is it to the x-axis? Well, the rest of 60 degrees, right? That will add up to 360 full on, right? So if I want to find sine of 300 and cosine of 300, all I have to do is know what sine and cosine of 60 are, right? It's the same as the reference angle. Now, except for what? In the fourth quadrant, sine is a negative, cosine's a positive value, right? Sine of 300 is a y-coordinate of an angle that fits in fourth quadrant, so it's going to be a negative. Now, what is sine of 60? Sine of 60, if you think back of your table, that's square root of 3 over 2. Cosine of 60 is 1/2. Boom. Okay, so that's where I'm getting these. So sine of 60, cosine 60, these values come from that table that I taught you how to immediately get. So we always going back to these, one of these angles. Okay. All right, let me give you another angle. What about if theta is negative 450 degrees? Okay, oh, I should have made it red. Okay, so let me draw this for you. Okay, it says to draw negative 450 degrees. Okay, I'm starting right here, and I'm in a negative direction. That's negative 360, so a full-on thing. Negative 360, and that's 90 more. That's negative 450, right? So it's coterminal with this angle right here. 360 and 90, yes. So there is negative 450. Now, we don't really need a reference angle for this angle because it happens to be a quadrantal angle. It doesn't fit in any of these quadrants. It fits on an axis. So what do I know about an angle that terminates down here? That's the same as a negative 90 degrees or so if you want. But this one's easy. Again, remember, you're on a unit circle. For the sine value of it, all you have to do is grab the y-coordinate of this point, which as you see is -1. For the cosine value of this angle, you simply have to pick the x-coordinate of this point, which of course you see is 0. So that's as easy as this. Okay. Now, let's think about this. What if theta is 7 pi over 6? Where is 7 pi over 6? Now, if of course you're good at all this trig stuff and you've practiced enough, you immediately will know where 7 pi over 6 is. It's 1 and 1/6, right? 7 over 6, by the way, is 1 and 1/6 of these pi's. So, easily, 1 pi and 1/6 of it. So it really fits right here, a little bit past, in the third quadrant. Okay, that's if you're good with fractions. If you're not, you're going to simply take this 7 pi over 6 and turn it into degrees. No one will get upset with you. So how do I turn this into degrees? Well, we practiced on this. You multiply by 180 degrees over pi. Boom, the pi is gone. These are reducible to 30, so that's the same thing as 210 degrees. And maybe that's easier for you to figure everything out on. So that's what I'm saying. So why we're still playing with these degrees, because it's much easier to find your way around with them. So 210 degrees, clearly 180 and a little bit more. Not only that, but it's now clear to me how much more did I go past the 180. In other words, what's the reference angle? The reference angle is what's made with the terminal side again and the x-axis, and that's 30 degrees. Yes. So what is the sine value of 7 pi over 6? Remember, that was our initial question. Cosine value of 7 pi over 6. Now, it's not, I don't mind if you write 210 in its place, because you have already shown me that you've changed 7 pi over 6 into 210 degrees. That's the same thing, but there it is nonetheless. So in the third quadrant, both sine and cosine are negative. Yes. So sine of 30 degrees is 1/2. Cosine of 30 degrees is square root of 3 over 2. Boom, done. Okay, there you have it. So that's how you find your way around. Again, you might take less or you might take more. On a test, I'm going to make you go through all the steps just to make sure that I know that you know. We're going to maybe go through a couple more, but that's really all there is to this section. Find your way around and know the exact values. Okay, so don't give me some kind of approximations out of your calculator. That is not what we're practicing here. Okay, so yeah, that's it. So let me just give you two more. What about if theta is, I'm going to go 3 pi over 4. That's easy. Where is 3 pi over 4? Okay. Same thing. If you don't like 3 pi over 4, maybe again you know your way around. You can multiply by 180 over pi. And that's a 45 times 3, it's 135. So 135 fits right here. 90 and 45 more. So we are in the second quadrant. So it's an angle in second quadrant. What is its reference angle? Is the, well, finishes it off to the x-axis. So the reference angle here is definitely 45 degrees. Good. So how do I find sine of 3 pi over 4? And cosine of 3 pi over 4? Well, again, sine is a positive, cosine's a negative in second quadrant. 45 degrees, that's a square root of 2 over 2. These are the answers. Boom, done. Okay. All right, I'm going to give you one more. So let's see, let's go round the circle a few times. I'm just going to pick something out of my brain. So what quadrant haven't we been in much? Okay. What about this? 1050 degrees. Yeah. All right. So definitely we need to bring it back down a couple notches, right? Where is 1050 degrees? Whoa. It's coterminal with something. Well, I'm going to go in a positive direction, but how many times? Let's find that coterminal angle. Yes. So I'm going to take the 1050 and bring it back first time around the circle, I like to say. So I want to find its coterminal angle, minus 360, and you can minus 360 again right away, because that's definitely not going to get you the first time around the circle. So if I start at 1050 and minus 2 360s, that's going to get me 330 degrees. And that fits between 0 and 360. So the first time around the circle. So now I know, yes, okay, fine. Go around 2 times, but then go to 330 and end right here in the fourth quadrant. Okay, so that's what 1050 is. 2 full 360s, right, to get you to 720. And then 720 plus 330 more get you for a full 1050 degrees right here in the third quadrant. What's the reference angle? The reference angle is what's left over to do or to go to till you hit back the x-axis, and that's just 30 degrees more, right? Okay, so what's sine of this 1050 and what's cosine of this 1050? Well, sine is negative in fourth quadrant, cosine is a positive. Sine of 30 degrees is 1/2. Cosine of 30 degrees is square root of 3/2. This is where these answers are coming from so nicely. All right, and that's all you're responsible for, knowing what the unit circle. Of course, I'm not going to draw this, but in your book you have the whole unit circle that really connects all of these angles. So really, if you think about this unit circle, what do you see? If you're straight across, yes, what's going to happen? These 2 points are going to be what? They will have the same y coordinate, but the x coordinates are opposites of each other, yes? For example, angles that terminate down here and here, in other words, all the way from here to here, or all the way from here to here, as you see, they have what? Same thing. Same y coordinate, opposite x coordinates, yes? And of course, these y's are negative. Let's just put that. So that's why, right? The sine values are the same. The cosine values are opposites of each other, right? Same thing here. Or you can be looking at your unit circle and look at what? Angles that end here and here. What happens with these angles? They have the same x, right? But they have opposite y values. Of course, the x's are negative, but yes, they're still the same. So again, if you look at the unit circle for the special exact values, you can build it really easily. I'm going to let you look at that on, of course, there's a ton of it on the internet, and it's in your book. So I'm going to let you look at the unit circle. You shouldn't memorize it. The fastest way is to really think about the reference angle, what quadrant you're in, and all you really have to do to have memorized is this really small table right here. And if anything, one liner, right? The other one is reversed. And then from here we can get the tangent, cotangent, secant, and cosecant in 5.3. All right, this was it.